Hello, I'm Jon Excell, editor of The Engineer, and welcome to the latest episode of The Engineer Talks, a series of short video interviews in which we talk to experts from across the world of engineering and technology about some of the key trends and topics that are shaping industry. This episode is the latest in a series of discussions around the net zero debate. When we explore that push for net zero, our focus on The Engineer is often on the individual technology areas and specific innovations that are going to get us there. But these technologies can only really have an impact if they're underpinned by sound understanding, consistent technical standards, validated test methods, and in a fast moving world of decarbonisation, setting standards is a particularly challenging business. I'm joined today by someone at the sharp end of this challenge, Ben Rowton, who's the Strategic Business Development Manager for Energy and Environment with NPL, the National Physical Laboratory. He's going to be offering some insights on the nature of these challenges and explaining a bit about how NPL is working with industry to create the technical standards and the sort of underpinning knowledge that are really key to driving forward the development and deployment of the technologies that are going to get us to net zero, including but not limited to the world of hydrogen and some of the developments that we're seeing there. So that's enough. That's enough from me. Ben, good to see you. Thanks for joining us today.
Morning, John.
So before we get into the main discussion, can you sort of briefly introduce yourself and your role within NPL?
Yeah, sure. You did a good role of introducing me. So my name is Ben Rowton. I'm one of the strategy leads within the Energy and Environment team at the National Physical Laboratory. So in my role, I engage with key national and international stakeholders within government, regulatory bodies, and industries of all sizes, really, to identify and prioritise the measurement challenges that they face in their decarbonisation efforts across the energy system,
Right.
from energy production through to end use. And these measurement challenges really kind of prohibit safe, sustainable, and economic development and deployment of technologies, systems, or changes that are needed to meet net zero targets. And with an understanding of these external needs, I shape programs of activity such that NPL can offer support and maximise our impact.
Right, great, thanks. And so I wanted to just sort of kick off with a bit of a kind of general question, really. I mean, NPL obviously works across lots of areas, lots of different sectors, grapples with lots of different challenges all across the economy. Net zero is possibly the number one priority, certainly across industry. How much of the organisation's time is taken up on, the kind of things that you're involved in?
It's a good question. I mean, personally speaking, supporting industry and government in achieving net zero targets for climate change is a core focus of our team.
Yeah.
We are only one of 4 national challenge teams. So there are others focusing on healthcare, prosperity and security. But with, public and private sectors investing heavily to investigate various decarbonisation efforts, transitioning from fossil fuels to hydrogen, directly capturing carbon from heavy industry, enabling flexible power grids. All of these efforts requires a huge amount of innovation and change.
Yeah.
And standards are quite crucial to support innovation and change. Much of what we do as the UK's NMI, National Measurement Institute, is focused on addressing measurement challenges and delivering pre-normative research that's needed to have confidence in some of these innovations prior to standards becoming available.
Yeah.
So the types of activity are important because they provide a framework for the innovation. They ensure compatibility, they foster trust, they facilitate competition, enable collaboration and support regulation, but also promote global integration, because some of these challenges aren't just UK centric. The hydrogen economy is an international focus at the moment. Even in America, the Department of Energy are about to release 8 billion into the hydrogen space.
Right. Well, I mean, let's talk about hydrogen because, we mentioned that at the beginning. There's been a lot of hype about hydrogen in recent years. It's clearly going to make some sort of contribution in different sectors of the economy. But, part of your role, I guess, is addressing that hype, cutting through it and helping to address some of the practical realities around commercializing some of these technologies that we've been talking about. So from your perspective, where are the knowledge gaps with hydrogen? What are the sort of obstacles to commercialisation, and how are you helping?
Yeah, I mean, I'll pick up on your first point. So hydrogen is only one decarbonisation pathway that's being investigated.
Yeah.
I mean, it's quite a versatile energy vector, and it can be used in many hard to decarbonise sectors where other sources like electricity may not be suitable. But it isn't the only solution required by a long way. And meeting any net zero targets require a large variety of change across the energy system.
Mm.
So hydrogen is just one of the key areas we're supporting. But the practical reality is transitioning to hydrogen has a lot of challenges that need to be addressed across the value chain. So, for instance, hydrogen is reported to have an equivalent impact on climate change 11 times that of CO2. So we need to ensure containment. We need to develop methods to ensure to be able to detect and monitor and quantify any leaks that happen. Materials behave differently when they're exposed to hydrogen when compared to other energy gases. So we need to understand and be confident that there's going to be no unforeseen detrimental impacts to the infrastructure when we transition across the hydrogen.
Yeah.
If you're using gaseous hydrogen for vehicles, it's not the same as petrol or diesel. So if the hydrogen isn't extremely high quality, it will cause catastrophic failure to fuel cell technologies, which you'll give fuel cell vehicles a really bad reputation from the get-go. So you have to avoid that at all costs.
Right. Right.
There are lots of other examples. Liquid hydrogen for aviation. You need to have knowledge of how traditional materials will behave at minus 53 degrees centigrade, and there's little information on that available. So there's lots of stuff around materials qualification, quality assurance, emissions, but also actually supporting the development of technologies. So if we want to start increasing the adoption of electrolyzers on our networks to increase the penetration of green hydrogen, but also to enable network flexibility between electricity and gas networks, we need to support UK supply chains, enable them to optimize designs and provide confidence to investors and adopters, and facilitate their access to international markets. Otherwise, we'll rely on importing these types of technologies to the UK, which then may offset the carbon to to however it's transported to the UK. Maybe it's shipping or aviation.
Yeah. Yeah. So there's a lot that needs to be done. Can you give us a couple of sort of specific examples of of how you're working with industry to help sort of address some of these challenges?
Yeah, so NPL, we're a partner on a project called the Hydrogen Innovation Initiative, also known as HI,
Yeah.
two I's for H2.
Okay.
So HI is looking to take a lead in shaping support across the UK to kind of anchor high value jobs, boost resilience, and speed decarbonisation by accelerating the development of critical technologies and supply chains. So the ambition of HI is to become an overarching national project that collates and coordinates activity, because at the moment there is a lot of projects regionally, nationally, across Europe and internationally, and we need someone to kind of man the ship, if you like.
Yeah. Yeah.
But more specific to the challenges previously mentioned, and this builds upon that picture that there are lots of different projects addressing different parts of these challenges. We have a project funded by the Knowledge Asset Grant, a government fund called Hydrogen Emission Measurement Services, where we're developing a facility that will enable us to characterize the performance of technologies used to detect and quantify hydrogen leaks. And we're in talks with partners across Europe to trial these technologies in live environments,
Right.
to develop standard methods for using them. We're working with the UK gas distribution network operators, providing them with data to qualify materials as safe to operate when exposed to hydrogen. And this type of data will be fed into the UK's Health and Safety Executive to progress large fuel switching programs. We have a project called MetroHive, or Metrology for Hydrogen Vehicles, again with European partners, that's investigating hydrogen quality control, flow metering, associated instrumentation at hydrogen refueling stations. We're trying to get a mission to the USA to learn about the requirements are to qualify materials as safe to use with liquid hydrogen, as they have more advanced knowledge on the topic developed by their international space missions. And then another large project we're working on is with partners across Greater Manchester, called the Greater Manchester Electrochemical Hydrogen Cluster. And that's directly supporting industry of all sizes that are involved in the supply and manufacturing of fuel cells and electrolyzers, trying to address key challenges and research topics and really boost that manufacturing sector.
Yeah. So a lot going on, and I mean, is this all relatively recent activity? Because it's only really in the last 3 or 4 years, I guess, that the talk around the hydrogen economy has really started ramping up.
I'd actually say we've been supporting hydrogen activities for some time,
Yeah.
probably 5 or 6 years, but
Right.
definitely seen a step increase in recent years, and probably a broadening of our portfolio. I think initially a lot of focus was around quality assurance for hydrogen fuel cell vehicles as they were being developed, but now whole grids are looking and investigating the potential to transition over from natural gas to hydrogen. There's more importance on some of these other issues like materials qualification and emissions.
Yeah. And being sort of, up close, if you like, to all of these sort of practical issues around the utilization of hydrogen. What's your, do you have a kind of a view on where it's going to fit into our future energy mix, how big a role it's going to play in the push for net zero?
As a National Measurement Institute, I'm always wary to quantify the size of the role, but
Yeah.
it's definitely going to, in certain industrial processes like because of the ability to store large quantities of hydrogen and heat it to very high temperatures, it makes a natural replacement to natural gas.
Mm.
So in certain industrial processes, it's very aligned, but there are other avenues that might similarly be more favourable to specific parts of society and the economy. So you're never going to be able to decarbonise sky-rise buildings using electric heat pumps, for example. So potentially in those situations, hydrogen boilers is more realistic. But then, the other option is distributed heating networks to provide domestic heating. So there are lots of different options, and I don't think you can really have a one solution fits all. Unfortunately, I think you have to go into the granularity about what's happening in region, what network capacity there is. There's not a simple solution, unfortunately.
Yeah, sure. Well, let's turn to some of the other decarbonisation routes, because there is no silver bullet when it comes to meeting our sort of sustainability goals. Can you tell us a bit about how you're applying the same kind of disciplines to some of these other decarbonisation strands?
Yeah, sure. So as I alluded to, this sort of standards are crucial to support innovation and change across the whole energy system, and not just for hydrogen. So we have a relatively formal process that we follow to identify and prioritize measurement challenges. So, which all start with engaging with external stakeholders all across the value chain, nationally and internationally, to understand their key challenges. So we have sort of similar activities around battery technologies, around carbon capture, usage and storage, smart grids and flexible electrical networks, and new nuclear technologies. And so for each area, we kind of, similar how I've gone through some of the key challenges facing the deployment of hydrogen as a decarbonisation pathway, we have a similar a view of the measurement challenges in each of these areas. And we tend to develop projects focusing on resolving these challenges in the different areas. In some instances, we're actually included at more at a national level. So take batteries, for example. There is a national program for batteries called the Faraday Battery Challenge, which is which is a program that is investing in research and innovation projects and facilities to drive the growth of a strong battery business in the UK. And we're kind of providing the support as a project partner at a national level.
Right. And I mean, it's a point that we've sort of come back to a couple of times in this in this discussion, but you know, there is no silver bullet. What's required is a sort of a joined up strategy. What would you say are some of from all of the different areas that you're involved in? Are there some common lessons there that apply across all of these key areas?
Yeah, so we work directly with industry to solve their measurement challenges. I think it's quite a complicated space. The innovation ecosystem in any country is vast. Just think about the number of universities and RTOs and non-government organisations set up to support various initiatives and activities. So I think the fact that these national measurement institutes and these national laboratories exist can be lost in the mix.
Right.
So that industry aren't aware that we're there to support them, and that we actually invest in the expertise and infrastructure to help them develop their products and services.
Yeah.
And to offer schemes. We even offer schemes. We have one running at the moment called Measurement for Business that provides us access to our scientists and facilities to support their kind of innovation pathway. So I don't know if it's a lesson learned, but I suppose just be aware of some of the key players in these innovation ecosystems and how they can support your innovation, your product.
Yeah. Well, it's an important point, isn't it? I mean, we see this with lots of areas. You know, it's often a general lack of awareness around the sort of assistance, help, expertise that's out there that you can tap into. So it's important to get that message across.
Exactly. I mean, for that's when we support industry, but for government, I probably have a different lesson, if you like, if you want to call it a lesson. So with some of these huge changes, you know, subsidies are usually the starting point to drive big change. You know, they're necessary to promote innovation as they provide financial support to R&D and correct market failures or encourage businesses to invest in ambitious projects. But sometimes there's such big efforts, and you know, it's very easy to focus on hydrogen or carbon capture and storage or electrification, that coordinated efforts are needed across at a national level, focusing on these different decarbonisation pathways with to share knowledge with one another and enable informed policy decisions to be made. And the most common issue I see, which we kind of alluded to before, is that some of these measurement challenges in this pre-normative research is often an oversight. It's not included at a national programme level. Right. Which kind of means that the developments are reliant on individuals identifying suitable opportunities to progress specific fields, you know, take hydrogen emissions monitoring, for example. But it's not part of any national hydrogen programme at the moment. So, I think a key issue there is that this standardisation and this developing the infrastructure to support and accelerate these innovations going forward should be a pre-thought rather than an afterthought.
Great. And if someone's watching and you know they want to find a way of tapping into the kind of assistance and expertise that you have at NPL, what's the best way to engage with you?
There's many ways to engage with us. You can the website's probably a good sole source of information. It splits into the national challenge areas and gives a broad overview of some of the different work that we're doing in those. And obviously there's contact us pages that kind of triages your interest to the relevant people within our organisation. And we're soon to be revamping our hydrogen landing page, our CCUS landing page, and some of the other activities we're doing in the space.
Great. Okay. Well, we'll flash all those details up on the screen in a moment. Ben, it's been great talking to you today. I think we're sort of just about out of time now, so thanks for joining us. It's a huge topic, and I'm conscious we could have discussed it for hours, but that's not the point of these interviews. So I think we've covered a lot of ground very well. And an important reminder to anyone working at the cutting edge of low carbon energy that clear standards are really, really key to delivering on the commercial success of technology. So I think it's it's an important point that's come across well in this discussion. So thank you for joining us. As I say, for now, I'm afraid that's it for this episode. But thanks for your time. Thank you everyone for watching, and take care.
Thanks, John.